So the last conic that we are going to study is called the hyperbola. Some people will call it the hyperbola. It is pronounced hyperbola. And we are going to do the same things. Write the equations, identify some major aspects of it, and graph it. Graphing form, there's actually two different forms for the hyperbola. And the main reason there's two forms is because definitely it's a subtraction problem. Now you can see in our second example here I have addition, but that's when I have my x term negative. So the idea is if it's a hyperbola, one of your terms is positive, in this case x, the other is negative, in this case y. It's still equal to 1. The rest looks exactly like the ellipse. The big difference is that you have one term negative. That's the difference between a hyperbola and an ellipse. You can tell the difference when you're going to graph or when you're looking at the equations just by looking for a positive versus a negative. The rest of this is all very similar. Your center is still located at HK. Rx is still considered your x radius, but it's going to do something different. It's going to kind of act a little bit different. It's going to be interesting to see as we graph it. The Ry is still your y radius, and C is still your focal radius. But we find it in a different way. It doesn't matter in this case whether x radius or y radius are bigger. It doesn't matter because when I'm graphing a hyperbola, it's not subtraction, but addition. So it matters when I'm graphing my ellipse because I have to subtract my rx squared minus ry squared. Here I'm not subtracting, so it doesn't matter. And then your foci, or your focus points, all have to do not with whether one is bigger than the other, your x radius or your y radius. It has everything to do with where your positive and negative terms are. So my foci, if my x coordinate or my x term is positive, then I make my adjustment to my center point, h comma k, to my x coordinate. So my focal radius is how much I am changing my center, but I'm only changing either my x or my y coordinate. I am changing my x coordinate, h, if my x coordinate is positive. So it's h plus c comma k for one focus and h minus c comma k for the other focus. If my y coordinate is positive, so that's an example, y coordinate is positive, that's when my x coordinate is positive. That's when I make my adjustment to my y coordinate. So h comma k, but I have to adjust it based off your focal radius here. Let's take a look at an example here. In this example, I know that this is a hyperbola because it's a subtraction problem here. I have a negative y. Okay? That means I can go, as soon as I see that my y is my negative, my x is my positive term, I know that when I'm going down here to find my foci, I'm making my adjustment to my x coordinate. So I can find my center at negative 2 comma 4 based on the x plus 2 and the y minus 4. I know my y coordinate isn't changing. It's just going to be 4. My x coordinate, which is negative 2, is the one that will be adjusted based off of this focal radius. So going ahead and finding everything else. If I plot my negative 2, 4 center for my hyperbola, my x radius is 6, my y radius is 3. I'm going to do the same things we did with the ellipse on those. X radius of 6 means I'm going to go 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5, 6 to the left, and an y radius of 3 means 3 up, and 3 down. But unlike an ellipse, in which case I would draw my curve here, I'm not going to draw a curve. I'm going to lightly make a rectangle. This is not technically part of my graph whatsoever. Okay? This is just kind of going to give us a guide as to how to draw my graph. The graph has nothing to do with that rectangle, though. What this allows me to do is draw in what we call our asymptotes. These are lines that will never be crossed, and those are our diagonals. So with a dashed line, draw in the diagonals of this rectangle and draw them all the way through. It's easiest if you use a straight edge. I draw these diagonals in. Now, we still have technically not drawn our hyperbola whatsoever. All we've drawn is kind of our framework that's going to allow us to come up with our hyperbola. I did all of that in a dark blue, so I'll actually graph the hyperbola in red. Now, I have two vertices. Your vertex for a hyperbola is always going to be not with x, not with y, but with whichever one is positive. X is my positive. That means that it's going to open in my x direction. My Rx is going to be my important piece. This vertex, this radius, is my important pieces. I need these to help me identify my rectangle and my asymptotes. This is going to go up this way but never cross that. Curve down this way but never cross that. And do the exact same thing in this direction. That's the graph of my hyperbola in red there. Now I do want to find the focal radius so I can actually plot down where our foci are located as well. That's where I take, I will do this in purple, my c is going to be equal to the square root of 6 squared plus 3 squared. So that's 36 plus 9. I square root that and I round to the nearest tenth. I get 6.7. That helps because that's what I'm going to add here and subtract here, my focal radius, giving me my foci at -2 plus 6.7 is 4.7 comma 4. So 4.7 is close to 5 comma 4 means my first focus is right about there. And then -2 minus 6.7 is -8.7 comma 4. There's -8, -8.7, up to 4. I've graphed my two foci. Let's go ahead and do the next one together as well. First thing I notice is that in this case my x is negative, my y is positive. That means it's a hyperbola because I have a negative. My y is positive. That means this is a hyperbola that's going to open up and down in the y direction. My center is at 3, -1. I can plot that. My x radius is 2. That means go right 2, left 2. My y radius is 3. Go up 3, go down 3. That gives me enough to make my rectangle. And it allows me to take my straight edge out and draw these asymptotes, they're called. You'll learn a lot more about asymptotes in Algebra 2. I already know that's opening up and down because my y was positive, so I can go ahead and graph my hyperbola opening up and down. I'm not looking for perfection. I'm looking to make sure you never cross those lines. Okay. Also, since it's opening up and down, I know that my foci, my x-coordinate, isn't going to change, but my y-coordinate is. It's going to be, for my y-coordinate here, -1 plus c, and my y-coordinate here is going to be -1 minus c, so we have to find that focal radius. If it's a hyperbola, that's rx, or 2 squared, plus ry, or 3 squared, all inside the square root. 4 plus 9, take the square root of that, round to the nearest tenth, I get 3.6. That's what I am adding here and subtracting here. Okay, so 3 and 2.6. 3, 1, 2.6 will be a little more than halfway. 3 and -4.6. There's -4, a little more than halfway. I've got my foci. Go ahead and re-watch those two examples if you're still struggling on how to find or graph, especially which direction. The direction always has to do with the positive term. In our last two examples, it's about writing our equations. So I can tell you that when you're writing your equations here, it's going to be very similar to the ellipse, where I'm not going to necessarily just automatically put a positive here, though. It's starting out like this, and it's filling in all of the rest of the details. My center is going to be here. That's at 1, 4. Means it's x minus 1, x minus 4. X radius, count from your center to the left or the right. 1, 2, 3, 4. Y radius is count up or down. That's 2. The last part about the hyperbola equation is deciding where is my positive and where is my negative. And that has to do with whether it's opening up and down or left and right. If it opens left or right, your left or right axis, x, is positive. This is a positive. That makes this negative, and it becomes a subtraction problem this way. The second example is very similar. Find your center. -2 means it's x plus 2, or -4 means it's y plus 4. X radius is 1, 2, 3, 4, 5. Y radius is 1, 2, 3. But in this case, it opens up and down. That means my y is positive. I have to make my x negative. That's the only way to make this work. Okay, those are all your videos on conics. Please re-watch any video on any conic or any topic that you're struggling with. Also, come in and get some extra help. Use the resource room or come in to see me before school.